Hello everyone and welcome back to the chemistry class. I'm genuinely happy and appreciate that you take off your time from your life in order to come back to learn and to grow. So for today we are going to take a look into the different aspects, different topics such as the greenhouse effect, global warming and certain types of depletions which are caused in the ozone layer, right? So let's start the entire topic, the class for today, with respect to the global warming. So when I say about global warming, it has a direct relationships with the greenhouse gases. Okay, now what are these greenhouse gases? How they are going to affect the temperature and how does it lead to the global warming? We need to take a look into all of these particular factors. See, when we take a look into a simplest type of gas, and that is going to be the carbon dioxide, right? So this carbon dioxide gas is a product that is a product of decomposition of matters, correct? So when we take a look into carbon dioxide, it is a product of decomposition of different organic compounds, right? Now, apart from this, the carbon dioxide is also going to be released into the atmosphere from different sources, such as from the internal combustion engines. That means it is derived from the vehicles, right? So as these particular carbon dioxide are also being released into the atmosphere because of the thermal plants, or we can just call it as the industries. Okay, so naturally what is happening is the concentration, these all things are leading to the increase in concentration. This increases directly the concentration of carbon dioxide, right? So when it increases the concentration of carbon dioxide, what happens is the temperature of the globe, of the earth, goes on increasing step by step. Okay, so this is one of the greenhouse gases. There are other greenhouse gases such as methane. Okay, there are CFCs, that is chlorofluorocarbons. We are going to speak about this in the further of this particular topic. Okay, so we have methane, we have chlorofluorocarbons, we have water vapors. Okay, even they act as the greenhouse gases. Now out of these all, it is actually the methane which constitutes almost like 15%. 15% of the total greenhouse gases. Okay, now what happens is these greenhouse gases, they trap the energy of sun radiations. Okay, they trap this particular energy, they convert it into a type of the heat and it does not release it outside. So now basically you need to understand how these particular greenhouse gases are warming up the temperature. Okay, so before going to directly the effects of greenhouse gases or how it works, you need to understand what exactly we mean by global warming. So global warming is nothing more than a warming temperature or a climate which is warmer than before. Okay, so the weather, or you can say as the climate, warmer than before globally. It is alarming condition, and this alarming condition is nothing more than the global warming. Now this global warming has a direct relationship with the greenhouse gases, as we have already spoken about different types of greenhouse gases, right? So now what exactly happens is, let us consider this as the surface of Earth. Let's consider this as to be the surface of Earth. Alright. Now, due to continuous release of this particular carbon dioxide, CFCs, methane or water vapors, what happens is these particular gases tend to get accumulated over here, okay, into the atmosphere. Now, these gases, they have a tendency to absorb the radiations from sun. Okay, as a result of which, what it does is it absorbs all these radiations from sun and converts this energy into heat. So what it is doing? It is converting this particular energy into heat. This heat energy is absorbed by the earth. Now, what is the conclusion? The surface of earth gets heated up, right? Now, as it gets heated up, it starts radiating the energy back. Now, as the energy is radiated back, now what does these particular gases or this cover of gases will do is that it will not allow this heat to go into the outer space. Okay, apart from this, what it does is it does not just reflect it, it is going to reflect these particular energy as a heat back to the surface of earth, a part of its energy. Okay, due to which the temperature of earth goes on increasing. So this is how it all works. Okay, so when we take a look into the greenhouse gases, these greenhouse gases, they literally trap the energy which they get it from the sun in the form of heat. They transfer this particular energy to the surface of earth in the form of heat. Okay, when the surface of earth starts getting heated up, it starts radiating the energy back. But the energy which is coming from the surface of this earth is not allowed to go back into the outer atmosphere. Due to this all cover of the greenhouse gases. Okay, so because of these greenhouse gases over here, these greenhouse gases, instead of letting this energy outside, it will reflect it back to the surface of earth, which will cause the increase in temperature. And this is going to cause a warmer climate globally. Okay, so any particular climate change or the climate which is warmer than before globally, we term that as a global warming. Okay, let us try to understand what are the harmful effects of this entire global warming because of the greenhouse effects. Okay, so when we speak about the harmful aspects, okay, now here the first thing that we need to understand is if this particular trend of increase in the greenhouse gases goes on increasing, then we might see an increase in temperature of 3 degrees to 4 degrees Celsius globally. Okay, we are speaking with respect to global temperature. So globally we can expect the temperature to rise by 3 to 4 degrees in degrees Celsius. Now, this particular increase in temperature globally, okay, what it happens is it has a direct relationship in melting the glaciers. Okay, so if the temperature is increased to 3 to 4 degrees globally, then the effect is on glaciers. The effect is seen on the ice caps. So the glaciers, the ice caps that are present in Antarctica, the Greenland region. Okay, so these particular things will start to melt. As they start to melt, water is formed in a huge quantity, which is released into the oceans. That means the ocean level increases. So the ocean level increases. So when the ocean level increases by 80 meters, okay, this is a devastating condition. More than enough in order to submerge the coastal regions. So this is the effect of the global warming. Okay, so I hope you understand now. Global warming has a direct relationship with the greenhouse gases. So when we say about the greenhouse gases, it is just not limited to only one gas. It is a mixture of gases. It can be carbon dioxide, water vapor, CFCs, methane, etc. out of which 15% is right from methane gases. Correct? So what these particular gases do is they trap the entire energy around the Earth's atmosphere. The energy in the form of heat which they receive from the sun's radiation. They convert this particular energy in form of heat and then they transfer it to the surface of Earth. Now, as the Earth starts getting heated up, this energy is reflected back, but the cover of gases do not dissipate this particular energy to the outside space. Rather than that, it reflects back inside again, back to the surface of Earth, due to which there is an increase in temperature. This increase in temperature globally, we call it as the global warming. We can see its effect as 3 to 4 degrees Celsius growth in temperature globally, which melts the glaciers, the ice caps, and it will cause a raise in the ocean level by 80 meters. Now, when it raises by 80 meters, the coastal areas are affected. Correct. So, this is about the greenhouse effect and the global warming. Let's see with respect to the next type of pollution, and that is going to be the stratoscopic pollutions. The next point of discussion is the stratoscopic pollution. So when we take a look into stratoscopic pollution, I hope you remember the stratoscopic region. Okay, so when we take a look into the stratoscopic region, it is a region which is above the troposphere, extends from altitude of 11 kilometers to 50 kilometers, right? Now, the problem in this particular region is that if you take a look into, let's say, that this is the surface of Earth for a moment, let's say, right? Now, our first region, what we have is the troposphere. Okay, now let's say this is the troposphere. Okay, now this troposphere is from 0 to 11 kilometers. Okay, so the next one, what we have is right from 11 kilometers from the surface of Earth to 50 kilometers, right? So this region, as what we are speaking, it is a region of stratosphere. Now here, the problem is once a particular pollutant in the form of gas, if it reaches this particular region, it stays there for a long number of time. For several years, these particular chemical substances would tend to stay there. Now, what kind of chemical substances I am speaking over here in this particular region is that the chemical species of nitrogen, oxygen, sulfur, okay, they tend to live over here, they tend to stay over here in this particular region for a great or for several years. Okay, now the most striking feature of this stratosphere is that this stratosphere contains a ozone layer. Okay, so this particular stratosphere is going to contain a ozone layer. Now this ozone layer behaves in a different manner in the upper atmosphere and in the lower atmosphere. Let us say that this entire stratosphere as what we have, we are going to divide it into two parts. Okay, that is, let us say this particular region over here, it will represent to us an upper atmosphere. Okay, and this one, let's say this particular region corresponds to a lower atmosphere. Okay, now this ozone layer, okay, it acts in different ways in the upper and in the lower atmosphere. Here we need to understand that the ozone layer is usually formed in the upper atmosphere and it is depleted or dissociated in the lower atmosphere. Okay, now let's try to understand how this ozone layer is Okay, so as I said, ozone layer is usually formed in the upper atmospheric region. Correct. Now let's say that these particular things over here are the oxygen molecules. So now what happens is, these oxygen molecules are under the effect of the ultraviolet radiations. So the ultraviolet radiations which are coming from the sun, okay, especially those which have the shorter wavelength. The shorter wavelength, in a sense, I am speaking over here, the wavelength smaller, okay, the wavelengths lesser than 250 nanometers. Okay, so when these particular radiations having the wavelength less than 250 nanometers, when they come and strike these oxygen molecules, what will happen is, because of these, the oxygen molecule gets photo-dissociated. So this particular process is photo-dissociation. Okay, so the molecule is getting converted into oxygen atoms over here. Now, a number of oxygen atoms are going to be formed. At the same time, some number of the oxygen molecules will be there. Correct. Now what will happen is, the oxygen atom will get combined with oxygen molecule, neighboring oxygen molecules. Okay, due to which it forms O3, and that is nothing more than the ozone. Alright, now here what is happening? The photo dissociation. Photo dissociation of oxygen molecule. Because of what? It's because of the ultraviolet radiations which are coming right from the surface of the sun, right? So now, this is our first reaction, what we see. Now due to this, the ozone is however formed. Now this ozone, again, it undergoes a depletion, and that depletion occurs in the lower atmosphere. So here the formation is occurring, right? Here the formation of ozone is occurring, and here what we have is the depletion. So depletion, the depletion of ozone, where it occurs, it is going to occur in the lower atmosphere. Okay, now quite generally how it is going to form this over here. Let's say these are your ozone particles over here. Okay, so now when a UV radiation comes, these ozone are having very good tendency to absorb ultraviolet radiations. Now as the ultraviolet radiation comes over here, alright, as it strikes again because of the photo dissociation, but now this time the photo dissociation is of ozone molecule. Alright, so these ozone molecules split up into oxygen molecule and oxygen atom. Further, again, these oxygen atoms are formed from oxygen molecule in the same manner. Okay, so here the entire dissociation occurs, here the formation occurs, and this is how a striking phenomena of formation and dissociation of ozone keeps on occurring in the stratoscopic region. Okay, so I hope you have understood about this, about the formation and the dissociation of ozone molecule. Now the next point, the next concept that we need to deal exactly is about the pollution occurring in this region. What we mean by pollution in this region is, what are the things which are affecting the ozone. Okay, so let's go for the next one. So the next point of discussion that we have is the depletion of ozone, right? So now this particular ozone layer, it is gradually getting depleted, and that is because of some serious issues from certain classes of hydrocarbons, and those particular hydrocarbons that are depleting the ozone layer are called as CFCs. That is nothing more than chlorofluorocarbons. Okay, so this chlorofluorocarbon over here, that is CF2CL2. This is a chlorofluorocarbon. Okay, Now the condition of this chlorofluorocarbon is, this is very stable. Okay, it is a very stable compound. Further, if we just understand about this compound, it is odorless, it is highly volatile, but at the same time it is inflammable. Now, because of these particular character, of course, when we take a look at its odor, it's odorless, it's tasteless compound, and it's of course transparent compound. Now, when you take a look at all these particular categories of properties, what happens is it makes this particular compound very ideal to use in the refrigerators, okay, in coolants, in air conditioners, in aerosols. Alright, so it finds a number of applications, and because of the human uses of these hydrocarbons in various technologies, these hydrocarbons, that is CFCs, are continuously being released into the atmosphere. As these get diffused into the atmosphere, what is happening is these CFCs are traveling all the way to the stratoscopic sphere, okay, to the stratoscopic region there, and they react over here with the ozone, which causes the depletion. Let us first try to understand how it reacts. Now, as these CFCs too are going to get released into the atmosphere, once they come to the stratoscopic region, what happens here is, at the first point itself, these CFCs undergoes photo dissociation. Okay, so when it is undergoing photo dissociation in stratoscopic region. Now, so in order to understand that, let's take this particular formula, that is CF2Cl2. Now, this photo dissociation is because of the strong ultraviolet radiations. So again, okay, due to which this particular thing splits. It breaks down into free radicals. So, as it breaks down into free radicals, let's have over here CF2Cl. This is our free radical 1 plus Cl, that is a chlorine free radical, that is the second one. Okay, now this fellow over here, this chlorine free radical is responsible. Okay, let's try to understand how it is going to react. So in the second step, what will happen is this chlorine free radical will start reacting with the ozone molecules. Okay, so as it starts reacting with ozone molecule, you are going to get over here ClO dot plus oxygen molecule. Now this ClO dot is nothing more than this particular thing is our chlorine monoxide free radical. Alright, so now this chlorine monoxide free radical is formed on reaction with ozone. Okay, so in the next step, this particular, that is the chlorine monoxide free radical. Alright, so this reacts with the oxygen atoms which are present in the stratoscopic region. As it reacts, what will happen is these two will get combined in order to give us oxygen molecule plus a chlorine free radical is formed back again. In short, it has broken this down. Okay, so it has broken this down to oxygen level. So as the steps passes by, as the number of steps passes by, a number of chlorine free radicals are formed. As a lot many chlorine free radicals are formed, they have a tendency to react with ozone, leading to the formation of oxygen molecule and chlorine monoxide free radicals. This is how the depletion is occurring because of the hydrocarbons such as CFC. Okay, the other way round is because of the nitric oxides. The nitric oxide, which is produced because of the reaction between nitrogen gas and oxygen gas at a higher temperature in supersonic aircraft. So when the aircraft is moving at the supersonic speed, the engine, the region nearby the engine, okay, there the nitrogen and oxygen starts to react, due to which N2 plus O2, it will give rise to NO. Okay, now this nitrogen oxide, what is formed? This reacts, these react with the ozone molecule in order to form nitrogen dioxide and oxygen molecule. So the second region is the nitric oxide. The first region was CF2, Cl2. Okay, so these are certain facts, these are certain points what we need to understand why the ozone layer is getting depleted. Now, as the ozone layer gets depleted, what is going to happen is that as it depletes, more amount of ultraviolet radiations are going to enter into the surface of Earth. Correct? Now, these ultraviolet radiations are not just simple radiations, but these ultraviolet radiations are those with a lower wavelength. Lower wavelength in a sense, higher frequency. Higher frequency in a sense, higher energy of the radiations. So therefore, it will cause a direct damage to the life that is sustaining on the surface of Earth. So in case of humans, it is going to cause sunburns, skin cancer, eye cataract. Of course, for the plants and animals, it is going to damage food. It is going to damage their lives. Correct. So that was the harmful effect of the depletion of ozone layer. I hope you people have understood all these particular concepts. Thank you for watching. Do take care. We'll meet soon.